Welcome to AI Frontiers, a podcast exploring the latest breakthroughs in computational linguistics and natural language processing. In today's episode, we'll be examining cutting-edge research that's reshaping how we understand and work with language models. Our focus is on recent advances in computational linguistics from May 15, 2025, representing some of the most innovative work in this rapidly evolving field. These studies offer valuable insights into how researchers are addressing challenges in reasoning, knowledge integration, and model optimization, pushing the boundaries of what's possible with language technology. Computational linguistics exists at the fascinating intersection of computer science, artificial intelligence, and linguistics. This interdisciplinary field focuses on developing computational methods for analyzing, understanding, and generating human language. Over the past decade, remarkable advances have emerged in this area, largely driven by increasingly sophisticated neural network architectures and training methodologies. The significance of computational linguistics has grown exponentially with the rise of large language models, or LLMs. These models have transformed human-computer interaction through applications like voice assistants, machine translation, content generation, and information retrieval systems. What makes these models particularly remarkable is their ability to capture complex linguistic patterns and generate coherent, contextually appropriate text across diverse domains and tasks. The first major research theme we encounter is enhancing reasoning capabilities in large language models. Despite their impressive performance on many language tasks, LLMs still struggle with complex reasoning, particularly in domains requiring logical deduction or multi-step thinking. Several approaches address this challenge. Chain-of-thought prompting encourages models to break problems into intermediate steps, making their reasoning process more explicit and improving performance on reasoning tasks. Researchers have found that by prompting models to think step by step, they achieve significant improvements on tasks requiring multi-step reasoning. Another approach uses curriculum learning, where models are trained on progressively more difficult reasoning tasks. Lee and colleagues introduced a framework that automatically extracts diverse reasoning criteria from model-generated chains of thought, moving beyond predefined strategy types limited by human intuition. A particularly striking insight from this research is that training data format, such as free-form versus multiple choice, has a far greater impact on reasoning behavior than data domain. The second prominent research theme focuses on retrieval-augmented generation, or RAG. This approach combines the generative capabilities of language models with the ability to retrieve and use external information, addressing one of the key limitations of traditional language models: their inability to access information beyond what was present in their training data. Several papers propose enhancements to RAG systems, addressing challenges such as handling long documents, optimizing the interaction between retrieval and generation components, and improving cross-lingual capabilities. For example, one framework enhances RAG by incorporating knowledge graphs to provide evidence-based responses, helping to address the hallucination problem in LLMs by grounding responses in verifiable information. Another approach tackles the challenge of cross-lingual retrieval-augmented generation, where the user's language differs from the language of retrieved information. These advancements in RAG are particularly significant as they help bridge the gap between the static knowledge encoded in language models during training and the dynamic, evolving information available in external sources. A third significant research theme centers on addressing biases and ensuring fairness in language models. As LLMs become more widely deployed in various applications, concerns about their potential to perpetuate or amplify existing societal biases have grown. Researchers are developing frameworks for benchmarking and verifying implicit bias in LLMs, comparing how different models perform in annotating sensitive content, and exploring techniques to mitigate harmful outputs. One study introduces a framework for measuring implicit bias in language models by evaluating pre-existing LLM logic in math problem datasets with socio-demographic personas. The researchers statistically validate the presence of implicit bias in LLM behavior and find an inverse relationship between question-answering accuracy and implicit bias. This reframing of bias is not only an ethical issue but also a technical one, reveals an inability of LLMs to accommodate extraneous information and could lead to new approaches for addressing bias. Additional research highlights the growing threat of dark LLMs, Models deliberately designed without ethical guardrails are those vulnerable to jailbreak techniques, underscoring the importance of developing robust safety mechanisms and ethical guidelines. The fourth theme involves optimizing and compressing language models to improve efficiency. As language models continue to grow in size and complexity, there's an increasing need for techniques that can reduce their computational and memory requirements without significantly compromising performance. One approach proposes using vector quantization to drastically reduce the parameter count and computational load of LLM output layers. This technique can achieve up to 99% parameter reduction in the output layer and a significant speedup in logic computation with only a marginal increase in perplexity. Given that the final linear projection layer often constitutes a substantial portion of a model's parameters and computational cost during inference, this approach could significantly reduce the resources required to deploy large language models. Other researchers are exploring knowledge distillation techniques, where smaller, student models learn to mimic the behavior of larger, teacher models, and pruning methods that remove less important weights or neurons from networks. These approaches aim to make large language models more accessible and sustainable, reducing deployment costs and environmental impact. Several key findings have emerged across the research papers examined. Lee and colleagues discovered that training data format impacts reasoning behavior far more than data domain, challenging common assumptions about how domain-specific data influences model reasoning. This insight could fundamentally change how researchers approach the development of reasoning capabilities in language models. Another significant breakthrough comes from research on continual pretraining for reasoning capabilities. Researchers show that training with synthetic data containing hidden thought processes can consistently improve performance across diverse domains, with gains of up to 8 points on the most challenging problems. In the area of model efficiency, vector quantization for compressing the output layer of language models achieved up to 99% parameter reduction with only a 4% increase in perplexity compared to full softmax baselines. Research on cross-lingual retrieval-augmented generation identified two key challenges. In monolingual retrieval settings, models struggle with response language correctness. And in multilingual retrieval settings, the main challenge lies in reasoning over retrieved information across languages. Finally, research on implicit bias in LLMs found an inverse correlation between question answering accuracy and implicit bias, supporting the argument that implicit bias is not only an ethical issue but also a technical one. Researchers employ several methodological approaches in computational linguistics, each with distinct strengths and limitations. Prompt engineering involves carefully crafting instructions to elicit desired behaviors without modifying model weights. This approach is accessible and efficient but may not transfer well between different models, and verbose prompts can overwhelm lightweight inference models. Retrieval-augmented generation, RAG, grounds language model outputs in external factual information, reducing hallucinations and improving accuracy. However, RAG systems face challenges in effectively retrieving relevant information, especially in complex scenarios requiring multi-hop reasoning or cross-lingual contexts. Chain-of-thought approaches make reasoning explicit through intermediate steps, enhancing performance on complex tasks while providing insights into how models reason. These approaches can be computationally expensive and may struggle with very long reasoning chains. Model compression techniques like vector quantization, knowledge distillation, and pruning aim to reduce computational requirements while maintaining performance, though they often involve trade-offs. Finally, specialized evaluation frameworks assess specific capabilities or biases that might not be captured by more general benchmarks, driving progress through clear metrics for improvement. Let's examine one particularly influential paper, the CoT Encyclopedia, Analyzing, Predicting, and Controlling How a Reasoning Model Will Think, by Lee and colleagues. This research addresses a fundamental gap in our understanding of how language models reason through complex problems. The authors developed a bottom-up framework for analyzing model reasoning patterns, moving beyond previous methods that relied on predefined strategy types limited by human intuition. Their methodology is particularly innovative, automatically extracting diverse reasoning criteria from model-generated chains of thought, embedding them into a semantic space, clustering them into representative categories, and deriving contrastive rubrics to interpret reasoning behavior. To implement their framework, the researchers collected diverse reasoning examples by prompting language models with various problems, then used embedding techniques to represent these reasoning paths in a semantic space, allowing them to identify clusters of similar reasoning strategies. The authors validated their framework through human evaluations comparing their approach to existing methods. Perhaps most importantly, they demonstrated that this understanding can be leveraged to improve model performance by predicting which strategy a model is likely to use for a given problem and guiding it toward more effective alternatives. This capability to not just analyze but actively steer model reasoning represents a major advance in controlling how language models think. Another significant paper focuses on continual pretraining for enhancing reasoning capabilities in language models. The researchers investigated how training with synthetic data containing hidden thought processes affects model performance across diverse reasoning tasks. Their findings are particularly noteworthy. Models trained with this approach showed consistent performance gains across various domains, with improvements of up to 8 points on the most challenging problems. What makes this research especially valuable is that reasoning skills acquired in one domain transferred effectively to others, suggesting a more generalizable approach to enhancing reasoning capabilities without requiring domain-specific signals. Additionally, the researchers observed that models trained with hidden thoughts learned to adjust the depth of their reasoning according to problem difficulty, a sophisticated behavior that mimics human reasoning. This adaptive reasoning depth demonstrates that models can develop more nuanced approaches to problem solving through appropriate training methods. The research opens new avenues for training more capable reasoning models that can generalize across domains, potentially expanding the applicability of advanced reasoning capabilities to a wider range of real-world tasks. A third influential paper examines vector quantization for compressing large language models. This research focused specifically on the output layer, which often constitutes a substantial portion of a model's parameters. The researchers achieved remarkable efficiency gains, up to 99% parameter reduction in the output layer and a 6x speedup in logit computation. What makes this work particularly significant is that these dramatic reductions came with minimal performance degradation, only a 4% increase in perplexity compared to full softmax baselines. This represents an exceptional efficiency performance trade-off that could significantly impact how language models are deployed in practical applications. Given that the final linear projection layer often accounts for a large percentage of a model's parameters and computational cost during inference, this approach could substantially reduce the resources required to deploy large language models. The implications are far-reaching. More efficient models can run on less powerful hardware, reducing costs and environmental impact while making advanced language technologies accessible to a broader range of users and applications. This research exemplifies how targeted optimizations can address specific bottlenecks in language model architectures. Looking ahead, several promising directions for future research emerge from these papers. Developing more comprehensive frameworks for understanding and controlling model reasoning remains a critical area, building on the foundations established by work like the CoT Encyclopedia. Enhancing cross-lingual capabilities in retrieval-augmented generation presents another important frontier, particularly as language models continue to expand their global reach and applications. Addressing implicit bias as both an ethical and technical challenge offers a novel perspective that could lead to more robust and fair language models. Further optimizing model efficiency while maintaining performance will continue to be essential as models grow in size and complexity. Finally, exploring personalization and domain adaptation for specific contexts and users represents an important shift away from one-size-fits-all approaches toward more targeted and effective language technologies. These research directions collectively point toward language models that are more capable, efficient, fair, and adaptable to diverse needs and contexts. This research synthesis was created using multiple AI tools working in concert. The content generation was performed by Anthropic's Claude 3.7 Sonnet model, specifically the Claude 3.7 Sonnet 20,250,219 version. Text-to-speech synthesis was handled by Google TTS technology to create the audio narration you're hearing. Image generation for visual elements was created using Grok. While this content has undergone human expert review to ensure accuracy and quality, Some oversights may remain in the final presentation. All references from the original research papers have been preserved to maintain academic integrity and allow listeners to explore the primary sources. This synthesis represents our commitment to making complex technical research accessible while maintaining rigorous standards of accuracy and clarity. To stay informed about the latest research syntheses in AI and computational linguistics, subscribe to AI Frontiers. Our service provides weekly updates on emerging trends and breakthroughs, in-depth analysis of cutting-edge papers, and interviews with leading researchers in the field. Whether you're a practitioner looking to implement the latest techniques, a researcher seeking to understand the current state of the art, or simply an enthusiast curious about developments in AI, our content will keep you informed about the most significant advances in computational linguistics and language models. Visit ifrontiers.ai/subscribe to join our community of AI enthusiasts and professionals. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.